So for the next objective, let's look at a sound system. Now be careful, a sound system is more than just background music or one or two sound effects. If you're going to do a sound system as an objective, that means it needs to be integrated into the entire program. So it means multiple background musics, it means multiple sound effects for everything that you can in the game. It means that the sound effects and the background music should relate to the context given what the user's seeing on the screen at that moment. So for example, if the energy is very high, then the background music should reflect that. If the game is supposed to be in a spooky state, then the background music should reflect that, right? So everything should work together and synchronously to make sure that the whole experience is very effective. Pardon me. And then the next one is artificial intelligence. Now this depends on the type of game you're building. So for example, if you're building a game similar to Battleship, then the AI is basically choosing a square to throw a bomb at, and then if they do make contact, how do they work around to continue finding that ship? Other forms of AI include things like chess AI, or if you're playing a game like a racing game, like the computer being able to drive around the track in a normal manner that simulates at least somewhat similar to a human being. In one of the future objectives, we're going to talk about something called pathfinding, and actually that's the next one. Let's just lead right into that now. Pathfinding is a very interesting one, and probably one of the more complex ones, if not the most complex of all the objectives that we're about to discuss. This is one that should take an advanced programmer in class a few days to implement. So unless you're brave and you got a lot of free time, you're probably going to want to stay clear of this one. So this is what pathfinding looks like. Imagine you have, where's my mouse? There we go. Imagine you have a room. And in that room you have a few walls, maybe another one over here. And maybe you have a player right here and you have an enemy over here. Now imagine the world is broken down into a grid system with a whole bunch of like boxes basically. Okay? And the idea is pathfinding is finding a path from a starting point to an ending point, from A to B, in this case from the enemy to the player, as efficiently as possible. So for example, the enemy might move down, across, all the way up, and then come across there. Another path that enemy might follow, it might be something like this. Or it might be something completely different. It might come all the way up here and around and then down. The question is, which one is the best path? So pathfinding is finding the best path. Now if you have a less intelligent AI, you may force upon it actually a less than optimal choice. So basically what happens here is you create a path, and a path is made up of straight lines and turns. So we have a starting point. So let's say this is a starting point of the path. This is your first destination of the path. Here's your second destination of the path. Here's your third destination in your path, and here's the final destination. So basically, if this is A, B, C, D, and E. Okay? Other paths may go from across and have more turning points. It depends on what you set up. So if we were to draw this path out, it would be saying A goes to B, B goes to C, and D goes to E. Sorry, C goes to D and D goes to E. And the whole goal here is really just A to E. But it has all these subpoints in between. So once you've found the shortest path using pathfinding, you use another algorithm called path following, which is another one of the objectives we're looking at. Now you don't necessarily need pathfinding to use path following, but pathfinding you do need path following to use pathfinding, because once you've actually found the path using pathfinding, you have to be able to follow along on. However, some forms of AI may just set up direct paths. So maybe you're making a game where it's like an espionage game where you got to get from point A to point B without being seen by all the enemies. Maybe you have an enemy that follows a consistent path. and just walks around in this endless square. You might have another one that just kind of walks up and down, up and down, up and down. And then you might have another one that kind of goes like this, and your goal is to get from here over to here without being seen by any one of these enemies, right? But they're all following their own given paths. So in order to make path following work, it's actually very straightforward. What you have is a series of destinations. So you start at A, and your current destination is B. So you keep moving along A until you reach the B destination. Once you reach B, then you keep moving along B until you reach the C destination. Once you reach C, you keep moving along C until you reach the D destination. And then you finish it off. Once you are at D, you keep moving along until you hit D, or E, sorry. And E just happens to be our final destination, so we are done. So that's the way it works. Now, of course, if you're creating one of these cycles down here, these path following things, then you have a bit of a different system, because then you got to start over again. So E would then connect back to A. So you create like a cycle or a loop. So that is artificial intelligence, sound system, pathfinding, and path following.